Hello, everyone. Hello. I think you're on mute.
Oh, I can.
Oh, there you go. No, you're good.
Hello. It was doing that thing when you share screen, you can't hear people. But anyway, hello.
Oh, phew. That's an undocumented feature, I would say. And yeah, hello to everyone, and thank you all for joining us for this month's AusIOT meetup.
Indeed, the August edition of our monthly AusIOT meetup. And it looks like our little community has grown. This is probably the biggest group we've had to start a presentation with. The theme of tonight is energy, loosely. Energy, power in IoT. Does that sound about right, Steve? Like, yeah.
I was going to say, you could say this is a powerful meetup almost, couldn't you?
Hey,
Hey, there we go.
it's going to be lit. Yeah, I don't know
Oh,
about
there
that
you
one.
go. There you go.
I'm learning. Oh, that's so fun. But in line with reconciliation, we always like to start our AusIoT meetups with an acknowledgement of country. I myself am on Ghana land in Adelaide. What about you, developer Steve? Where are you?
I'm in Waganga land in Dubbo, or near Dubbo in country New South Wales.
Beautiful. And my family has actually been on Ghana land for 6 generations, my mum told me yesterday. So I definitely like to pay respects to the traditional owners of this land who've been here many, many, many generations before me and recognise that sovereignty was never ceded here. So yes, I am in Adelaide, and it's great to have a crowd of all of you from all over Australia here. So pop in the chat, let us know where you are, what country you're on. And yeah, pay respects to the traditional lands on where all of you guys are. Thanks, Ali, for getting us started. So today's agenda is going to be full packed, jam-packed. We'll start off with developer Steve and I bantering a little bit about what we've heard in the news lately with IoT. Then we'll go to our first talk, which is from Harald, who's joining us all the way from Germany. It's about 10 a.m. in Germany there, so thank you for that. And he's going to be talking about some research that he's been doing over there with energy consumption with some specific IoT networks, so namely narrowband IoT, LTE-M, and some other ones. I might have botched the title here a bit, but Howard can tell us what he's talking about later. Then after that, so after about half an hour of that, we'll be joined by Robert from SA Water, so a local guy over here in Adelaide, and he'll be going through the Zero Cost Energy Future program they've got, how IoT works into that, and specifically about the IoT side of things. Then after those 2 talks, we'll ask anyone who wants to share a project or talk about what they're working on to share that with us. And then we'll close this presenter mode and go back to those funky remote tables. So you guys and gals can jump around on different tables and network and talk to each other. So you can hang around as long as you want. I welcome you to go and grab some dinner, sit down and like listen to these talks with some dinner, have a drink of water, have a cup of tea, whatever. Post in the chat whenever you have questions for our speakers or for us. There's a Q&A function in Remo there too, where we can actually upvote questions. So if there's a lot of questions, we can do that. That's about it for the agenda. Maybe developer Steve, I'll get you to run through where we are, what we do here.
Oh, what's this venue? No, I'm joking. Welcome to Remo. Welcome to the virtual venue. So you can turn your chat on at the bottom of the menu bar. You would have seen that at the bottom when you first came in. You can't do it right now because we're in presenter mode. But when we go back to tables, if you want to put on your voice or you put your camera on, you can do that. Totally optional. There is also a chat function on the side as well. Spoilers for the developers in the room, you can put HTML tags in there, including marquee, which is one of my all-time favorites. So on the, not in this view, this is presenter view, but back on the table view, if you want to jump around to different tables, you just click on them and it'll move your avatar over to there, and you can have completely different conversations. So you can jump around and talk to folks and geek out, which is one of my favorite things to do. Also, I am a big fan of the island map. What else is there? Like Michelle said, in presenter mode, there's a Q&A tab to put questions in if you've got any questions, or you can put it into the chat as well. We'll be monitoring both, so either one will work fine.
All right. And if anyone who hasn't joined Remo before, it's really fun. So looking forward to the networking part. What have we got here, developer Steve?
Oh, sorry, I was too busy typing to Ali's marquee. Oh, see, I do like marquee. That's what marquee does, for those that haven't seen it. I miss that as a HTML tag. Anyway, we do have a code of conduct. It's on our GitHub. actually, I think it might be the AusIOT meetup. Anyway, it's on our GitHub. We might have to update that. I think we said that last time. Anyway,
Yeah,
spoilers.
this is the when it used to be just Melbourne before we expanded virtually into
That's
the
right.
ether. So yeah.
Anyway, we have a code of conduct. Basically, just be excellent to each other. But I mean, as a community, we normally that's how this community works, which is great. That's how most of the open source communities work. If anyone does have any concerns with the Trevor, it almost worked. If anyone does have any concerns they want to talk about, please feel free to grab myself, Michelle, or developer Ali, and we can jump up to the stage and have a chat, or reach out through the meetup group. I think we also have a Discord too, don't we, Michelle?
Yes. Is that on here? No.
Yeah, it's coming up.
We'll talk about that.
I was throwing out of sequence. Yeah.
Anyway, I've already gone to the next slide, so we'll talk about the next slide. Thank you to our hosts that are putting on the AusIOT meetup. We've been doing this together for over a year now, which is exciting. We've got Ali from IBM, who's here supporting the virtual venue. I myself are from Telstra dev.telstra.com, and we've got developer Steve from sneak.io. So if you want to know more about any of those, you can talk to us, but otherwise, energy saving in your IoT deployments. Oh, that's the topic of today. That's the whole,
yes.
I don't know why that's there. That's the theme. That's the topic of today. But we can go on to news and cool stuff now. So this is something that I picked up in all my newsletters and spam that I get that I actually look at. I noticed this headline grabbed me, like, why energy management is critical for 5G. And I thought, hang on a second, like 5G is actually much more energy efficient than previous IoT networks. What are they talking about? But the point is that even though an individual device using the 5G network might be more energy efficient compared to, say, 4G or whatever, there's going to be more 5G devices doing more things. So you have to consider that scale as well. So this kind of was a different way of thinking of it. I didn't read the whole article, but it was just a good thought trigger. So if any of you guys have considerations or advice on power and energy when you're actually moving to scale and how we're going to make that more efficient, then I'd love to hear you. I've also been looking into this recently. So Department of Home Affairs has released their cybersecurity strategy last year. And this year, recently, they released some policy recommendations for how we can maybe standardize cybersecurity on IoT devices. And in particular, they suggested a label rating system. And so I've been reading this paper and attending some open discussion with Department of Home Affairs. Anyone can join, and they're seeking inputs on these until August 27. So if you guys have any sort of stake in, imagine if the Australian government decided to set minimum standards for cybersecurity on IoT devices, that would impact all of us in a lot of ways. So if you have any feedback for them, being IoT experts yourselves, definitely recommend you get into that.
Oh, wait,
and developer C. Oh, yeah.
Oh, can you go back? I was just going to say, I've been also very closely following this one too, because it's one that I've been following, concerned about, just following in general for a number of years. This actually covers not only consumer-ready devices, but also industrial devices as well. So I think this one's going to be really interesting. And I think from an IoT point of view, the interesting thing with this is how do you apply those sort of rulings to very low powered, very low scale devices. And already, you can do, with a lot of the new boards, you can do X509 certificates on them to do a more secure handshake back to your server infrastructure. Anyway, I would totally recommend subscribing to the newsletters that come out for this one, because it's pretty big and it impacts everything we've kind of got in play at the moment. If you think all those Wi-Fi light bulbs that are out from, I'm not going to mention brand names like Kogan, the sort of security behind those are, they're fairly light. So
one of the things it mentioned was an example about how a casino in America was hacked through, and the point of vulnerability was a temperature monitor in the aquarium. And so you wouldn't think about putting 5-star security on your temperature monitor, but that's actually the point of vulnerability to take down an entire casino. So it was a really interesting read. If any of you guys are keen on this too, let us know. We'll have a Discord channel maybe about it.
Actually, we should totally do. We'll do that. And even NASA, the likes of NASA, they've been compromised before with an air conditioner monitor, similar to that one. So it's definitely emerge, like the cybersecurity on IoT is totally an emerging thing, and yeah, I think it's gonna turn around pretty quick.
So industrial IoT is like a given, but I've been thinking about the consumer IoT in the sense that, like, Aussies go to Bali and buy their, like, knockoff Ray-Bans, and it's not going to hurt anyone. But what if Aussies are going to Bali and whatever, or Thailand, and bringing back like knockoff augmented reality glasses or knockoff Garmin watches that are like IoT vulnerabilities? Anyway, I digress. Let's talk about something else before I talk too much. Go, developer Steve. What's this one?
Shout out to Craig Murphy, who posted this one in the Discord the other day. This is a off-the-shelf, fairly low-expensive robotic arm project that's kind of cool. Not only does it use the Arduino MKRs, which I absolutely love. In fact, here's one I happen to have sitting next to me. Which means you could basically connect it to Cat M1 and send like SMSs to it and stuff. Be kind of fun. You could do a game of chess that way. Anyway, side projects for Christmas. This is a really interesting project, and it's all open sourced. All the bits are through. There's some 3D printed parts on there. Everything's in that GitHub. So really interesting project. In fact, you could almost say that this robotic arm is a handy project almost. Couldn't you, Michelle? Hey, I had that one. I was saving that one up. It doesn't use ARM chips though, so just saying. Anyway, on that note.
On that note, if you guys have any projects or news or cool IoT things to talk about for our next meetup, let us know between now and then. Here we go. We've been waiting for this to come up. We've got a new Discord channel. Developer Steve, do you want to tell us a little bit about why you're excited about our Discord channel?
Yeah, because everyone gets to geek out like all the time. And
you don't have to wait for the monthly meetups. You can catch up outside.
There's already been some great combos in there. Christopher Biggs, one of our longtime favorite people, was all sharing some of his projects recently in there as well. So yeah, there's been some really great chatter. If you're not a member, please feel free to join. The whole Discord is under the same code of conduct we use for our meetups. So again, if you have any problems, concerns, just reach out to one of the admins and we'll have a chat.
Yeah, I love this. And it was kind of born out of the idea that we didn't want to just save all of our chats for the monthly meetups. We wanted to kind of democratize, like, we have all these great IoT enthusiasts as part of the AusIOT community, so they can help each other and share cool things in this channel. So love that. All right, enough from us. We've talked a lot. I think it's been a great chat. It's been great to chat to you, Developer Steve.
It's always good to talk to you, Michelle.
Yeah.
We always geek out. We've done some demos together. That was always fun.
That was always fun. It's still fun. When are we doing our next demo? We're gonna, maybe our next AusIOT meetup, you and I can do something. Anyway, It's not our turn today, it's Harold's turn. So Harold, if you would like to turn your camera on, you'll be able to join us up in presenter mode. Harald is, like I said, is coming all the way from Germany today. He's the author of the IoT M2M Cookbook, which is actually, also got a blog about all of this. He's been writing about IoT for the last quarter of a century before IoT was even called that. He's one of the fathers of IoT, I would say. Is also co-founder of the akorIoT idea. So maybe Harold, you can mention a bit about what that is as well. I love this though. Harold's personal mission is none of his customers should reinvent the wheel. I love that. So making sure that he's knowledge sharing through these blogs and talks like this so that we can learn from each other. I love that these IoT updates can be shared across the world. So Harold, are you there? Come on your video and turn your mic on. But anyway, while he's getting ready, I'll just introduce the topic, which is a low power wide area network comparison. So if you guys haven't heard this acronym before, LPWAN, low power wide area network, some of the technologies, and that refers to the technology that is actually the network connecting your device to the internet. Some of these is NB-IoT, LoRaWAN and Sigfox. There's others, of course, but these are the ones that we'll be talking about. And yeah, talking about the energy comparison between those. This is actually a talk that Harold presented in Germany before to one of the telcos over there. So we're very privileged to have him, if we have him. Harold, are you there?
Yeah, Michelle.
Perfect.
So microphone is on, and I think the presentation is working. I will share my screen. Yeah. So let me try again. Window sharing, and then.
Just while you're doing that too, again, if anyone has any questions, put into the chat or into the Q&A section, and we'll ask them at the end.
So can you see my screen? I think yes. So I have
Perfect.
Leave you to it, Harold, and we'll come back in about half an hour. Thank you.
Yeah. Okay. That means you can see my screen, Michael.
Yes, we can see it. Yeah, see your screen. We
Okay,
can see
fine.
you. Looks good.
Yeah. Okay. Everything is working. I already changed to slide 2, so everything is fine. Yeah. The topic of my presentation today is energy consumption of SMS. Yes, narrowband IoT, LoRaWAN and Sigfox for 12 byte, 25, 64, and 512 bytes. This was the presentation is based on a study we made for Deutsche Telekom. So they placed an order with us in, I think, September 2020 here, and then we made real measurements. You will see that in the next slides here. I'm the sales director with Tekmodul. Tekmodul is the biggest distributor for a well-known brand name of let's say cellular modules worldwide. Yeah. So we are the biggest distributor, and our supplier is the biggest manufacturer in cellular modules. Yeah. And in parallel, I'm the author of 2 books. The IoT M2M Cookbook I launched in 2014, and the LPWAN Cookbook is not getting finished because I get orders for studies. Yeah, that's the reality. So I postpone always the book. However, sooner or later it will be finished. I will go ahead. A little bit about my milestones. Yes, so the first biggest LoRa project, yes, not LoRaWAN, because at that time there was no LoRaWAN. I was in charge, so I was the FIE for future electronics and catch up the business. In 2014, I launched my IoT M2M Cookbook. And yeah, then the Gillette order button and a lot of things more. I will not explain everything here. Here is then in 2021 the finished study for Deutsche Telekom, and this is that where we stay today. That means I'm talking to you in Australia about the results we made here, and the next event coming up is the wireless congress in Munich, and I have there again the antenna workshops. I am doing the antenna workshop now, I think, at the 5th time in a row. Yeah, in parallel, I have my own boards. You can see the worldwide first Arduino shield was made by my team. The first message in the public narrowband IoT by Deutsche Telekom was sent by my team. Yeah, we have the worldwide first reference design with embedded antenna, and we are already in generation 2. So this PCB business, let's say, making reference designs is growing well. In parallel, we make customized antenna designs, and I can tell in the moment until we have 4 antenna projects in Australia in parallel here with 3 companies, and number 5 is already asking. So we make different antennas in different shapes and different technologies. And what I can tell for all of them, you cannot do it with a standard chip antenna, so you have a need for a customized antenna. By the Gillette button, the reason was mainly price. Yeah, so it has to be cheap, and cheaper here, and we made it cheap. The PCB, you can see that later on, is a 2-layer PCB. We also do simulations of antennas. Yeah, you can see here PCB antenna, a 1-to-1 copy of the TI reference node. Yeah, and not working here. And on the second side, you see the same PCB with some changes. So we changed the antenna from an L antenna to an F antenna. The F antenna has a switch. You can see here that the metal plug is is taking the energy from the antenna. This here is gone, so we make some RF tricks to isolate the plug. You can see that here current is flowing in the PCB here, and this is making only heat and now radiating energy. And here you can see the energy is mainly in the antenna, and nothing is in the PCB. These are the the 5 PCBs we made for the tests here. They are all the same shape. The size is credit card. Yes, we made some antennas inside. The embedded antennas in our PCBs was not in use for the test setup. You will see it later. This we made in that so that people can copy it to reproduce our measurement setup, but also to reproduce it and make maybe some kind of own PCB layouts here. The people has not to finish the layout. This can be done by my team. That means if you have a starting point like here or like here, we can optimize it. Yeah, this is now the one of the PCBs of our test in Germany. So we take everything in the basement. Yeah, that means we have a real wireless module talking to a real base station of Deutsche Telekom. We changed the link budget, yeah, and we changed the number of bytes per message. And yeah, here you can see it in detail. Yeah, so the PCB, then we put it in a shielding box. So the coverage of narrowband IoT of Deutsche Telekom and Vodafone is so good, yeah, that we have to limit the energy in the basement, yeah, to achieve then the 154 dB link budget. The 165 we did not try because then you run in trouble. You have always a jitter. That means the 155 are not static. There is always some noise. So 154 dB link budget, I think, is the technical limit. Yeah, then we use a Casely tool, but it's not too expensive. It is a, let's say, a tool for in the near of €1,000. This tool has an ultra high sampling rate. We made a measurement each 3 microseconds. The tool itself is already building an average value internally. This means we get each 36 microseconds an output here, and this 36 values we compressed again here, so that we was able to make it visible in an Excel file. Yeah. So this is all explained in the study, so everybody can copy it. Sorry, the phone was ringing. Yeah, it's business time in Germany. So yeah, and then we balanced the bytes. Yes, we used UDP. Yeah, not we used now TCP. On top of UDP, we had CoAP. Yeah, not MQTT. The reason is MQTT is killing the battery. This is not the topic of today. Yeah, so comparison of UDP and MQTT could be another comparison, or let's say another measurement report that we can do. Yeah, what was the result? Yeah, before we started, we calculated. Yeah, so this is a calculation that I made to estimate what will happen if we compare everything. And I was sure in the beginning that narrowband IoT will the better solution. Yeah, this is the calculation. I have an Excel file where I can tweak a lot of values. Yes, and if you do it right, then you come to this result. You can see we have here 134 dB link budget, we have here 144, and we have here 145. And what you can see is Sigfox is balancing nothing. That means they have always the same high energy consumption. Yeah, so they regulate nothing. Yeah, you can see that with better link budget, yeah, narrowband IoT is better than LoRa. Yeah, LoRa is transmitting once, yes, and has a very high package loss. So I calculated with 2 packages and with 3. That means 1 repeating or with 2 repeating. And you can see narrowband IoT is better. In a narrowband IoT message is already 1 repeating included, and they will balance the repeating on its own. So the protocol is doing the repeating. And you can see if the link budget get better, then even sometimes LoRa is better than the narrowband IoT. So that means in short distance, yes, LoRa could be better than narrowband, but in, let's say, medium distance, then narrowband IoT is better. If you balance to a higher link budget, then you can see that narrowband IoT will charge more energy, but LoRaWAN is already lost. So they cannot support 154 dB. So the high link budget of LoRa is based on marketing and is working in the laboratory only. As soon you go in real conditions, yes, it is not achieving the same than with narrowband. That means narrowband IoT has a higher energy consumption if it comes to higher link budget, what is okay. Yeah, and LoRa is already lost. And here you can see in the higher link budget, there is really Sigfox better. But if you build the average of all, let's say from low link budget to high link budget, then narrowband IoT is better. So there is no absolute answer. You have to compare the conditions and you have to compare the average. This is now a slide out of the measuring report. So we made thousands of measurements and built averages, and this is the output. And you can see here again, yeah, that what we have calculated here, we got in the end, yeah. And I included then SMS as well, yeah. So, and if you compare, SMS is not too bad. That means in the medium range of distance, SMS is worse than narrowband IoT. If it comes to high, you can see here the highest link budget with SMS is 144 dB, and if you send the same number of messages with an SMS, then it is what is it? Then it is lower. It means narrowband IoT is taking 10% of the energy than an SMS. Yeah, and if you go 10 dB higher, you can see okay, the energy is rising. What is common? Yeah, so 10 dB means that you have to spend much more energy to cover the distance. The same again with 24 byte, yes, and you can see if you see here between. Let's look on this bar because this you can see easy. The delta between 24 and 12 byte is almost nothing. So the most energy narrowband is using to set up the communication, and there is no big difference if you go down to 100 to 64 bytes. You still are in the near of 5,500. Even if you go to 512 bytes, then we have 5,600 milliwatt seconds. Yeah, and all the other guys, yes, are lost. Yeah, so as soon you come to 24 bytes, yes, as more bytes you transmit, as better looks than for narrowband IoT. So Sigfox is totally lost, yes, and LoRaWAN as well. Yeah, and then 512 bytes. I think this is something what you can do with narrowband IoT easy. And we in Germany, in Europe, we have duty cycle. For us, it's allowed to transmit 1% per hour. That means I have only 36 seconds for transmitting in the upload, and a package on LoRa is staying very long. So for 512 byte, I have to wait. I cannot do it in the same hour. So I have to wait more than 1 hour to send the last bytes. Yeah. This is just to show you the table. So I will not go in detail but we measured everything in several times. We built the average. We made the measurements with 3 different narrowband IoT modules. One of them was a multi-mode module. If you go in the tables you will see there is a small difference. So one module is better than the other. And in the end, we built the average of the best, of the middle, and of the worst module. The delta is not much, and the tables that you can see are the average of the average. Yeah, and here all together again, so all the PCBs, all the measurements, the PCB layout, the Gerber files, the study and the return loss of the antennas is public for everybody. And this is all, yeah. So I can say thank you for listening, and now I'm open for questions.
We have a question in the chat from someone. Will you be doing any comparison studies on WISE IoT standard in the future?
Yeah, as soon somebody is wiring some money, I do everything. Yeah. So this study was financed by Deutsche Telekom. I have good news for everybody. The next financing is already done. I have €0 antennas for all of you. So I'm working on that already. I analyzed the 3 PDFs of TI with all its bugs. There are mistakes in. The oldest file is from 2007. I will correct it. NeoCortic is financing. NeoCortic is a company in sub-gigahertz mesh net. So we combine the sub-gigahertz mesh net on battery with narrowband IoT and LTE-M. And a company that has a need for, let's say, 868 and 950 megahertz antennas is financing the €0 antennas for narrowband IoT and LTE-M, because I will show you how to migrate. You can see my screen, Michael? Yeah. So there is a classic F antenna, yes. And if you build this classic F antenna right, then you get for Europe an antenna for band 8 to band 20, what means 160 megahertz bandwidth. In Australia, your necessary bandwidth is smaller. We have 2 bands in use. So Vodafone is on band 20 and Deutsche Telekom is mainly on band 8. That means if you would come to Germany, the effort for antennas is higher than in Australia. However, I make it ready for the rest of the world, for all the bands, and everybody can copy it.
Nice. That's awesome. I love that.
Yeah, I just need income money to find. So that I do that all in my spare time. Yes, so that means evening, morning, or on the weekend.
Yeah.
Yeah. The measurements, for example, for the energy study was made by my business partners at akorIoT team. Yeah, so they developed the PCBs, they made the measurements, they just sent me the reports, and the writing was my part. Yes, the antenna study is my part. I will split it in my team in 2 directions. So some of the things I can explain very well with simulation. So I have a need for 10 different PCBs close the same to explain some things. And this PCB I need in 5 times. That means I have to produce 50 PCBs. What is too expensive? Yes, and so some things I will explain by simulation, and other things I will explain with real PCBs. That means 2 members at the akorIoT team will feed me with information, and my part will be again to take the reports and to write the text.
So with this research, how have you seen some use cases change the way that they choose the IoT network? So have you seen anyone, you've shown these findings to them and then they've changed the decision on the network, and what does that look like? What are some of the use cases?
Let's say, so okay, I'm a fan of narrowband IoT, so I'm in with narrowband IoT from day one. So Deutsche Telekom invited me in 2016 to be a part of their study. Yeah, and this time we made a decision to develop an own first PCB and Arduino board. What I can tell for Germany, but I think I know the maps for Australia. Yeah, there is no Sigfox network. Yeah, so you can come over to me and we can go down to my basement. Yes, you can take your nice phone. Yes. And you can make calls on GSM, yes, with telephone, with Deutsche Telekom, with Telefonica and Vodafone, yeah. But there is no Sigfox coverage in my house, in the kitchen, yeah, even in the living room. So basement is nothing. We can then move to the next 3 cities with the same result. There is no Sigfox indoor. That means there is no network. They have a little bit outdoor, but indoor nothing. With LoRaWAN, we have the same situation. We had 3 companies, yeah, that tried to cover Germany with a LoRaWAN network, all 3-fold, yes. And now there was number 4 and number 5. One was from the States, another one was from Malta. I'm still waiting. Nothing will happen. Yeah, they are too late. And what will happen soon is that Telefonica will pop up with antennas for narrowband IoT and LTM as well. So why I should, if somebody comes to Germany and would like to make LPWAN business, then the narrowband IoT is the way to go. However, I have a LoRaWAN project as well because there are, let's say, some applications where LoRaWAN is nice. If there is no network, yes, then you make your own network. But you have to be aware on the limitations. The second study, what I have written for Deutsche Telekom is smart city on public network or on private network. Yeah, and I have not written narrowband IoT and LoRaWAN. Yes, I have explained a lot of applications, and I am showing what is possible with which technology. I explain in detail what you can do with LoRaWAN, but my recommendation is do it not. Yeah, and if you do it, then just limit it to spreading factor 7. Yeah, if you go higher, then you move quickly in packet loss. Yeah.
Yeah, amazing. We have a question. We actually have a few questions. We have another question just came in. Anyway, first question is Scott Williams. Hello, Scott. Said, awesome presentation. Most applications I have are designed for PCBs that are fine with link budgets under 100 dB, both NB-IoT and LoRaWAN, either urban environments with plenty of gateway tower coverage or rural antennas that have high directivity gain. For applications less than 200 bytes per packet, is the
LoRaWAN is the most effective per packet. And just furthermore, I understand that NB-IoT
is the most effective at 512 bytes plus. So I think this is more about a throughput bandwidth to cost question.
Now we can go back to the 12 byte. Yeah. What are the, let's say, what are the mistakes and bugs in the LoRa presentations? Yeah. First of all, they tell you they have minus 107 dB sensitivity. This is true, yes, if you are in the laboratory. The next limitation with LoRa is you can receive 20 dB under noise floor. Yeah. And they calculate on the thermic noise floor in the laboratory. The real world means minus 100 dBm, yeah, in a German city, and the same you have in an Australian city. If you go in an industrial plant, you come to minus 90 dBm noise floor in the industrial plant. Let's go back to the city. Minus 100 is not what we get. You can receive a signal under 20 dB under noise floor. That means the limitation is minus 120, maybe minus 125 dB, and never ever minus 135. And this is happen then in our measurement setup. We was able to transmit on 154 dB link budget, and LoRaWAN not. They cannot do it. That means you have endless energy to transmit your 12 or 64 byte because you will not receive anything. The next what they do is they only tell you the energy consumption for one package. Yeah, no repeating. This you can see in my first and my second study. I have I linked several studies from other people that make some studies on energy consumption as well. And if you come to maximum link budget, then the loss of packages is higher. Yeah, the coverage record of LoRaWAN is more than 700 kilometers. So they're transmitted from the Netherlands up to a balloon flying already in Poland. Yeah. What they don't tell you is the number of package loss. Yeah. So maybe they received one package, yes, but they lost 99. Do you know? Nobody knows. Yeah. What you can see in this one study from Singapore is that as higher is the distance, as higher is the package loss. So to calculate one package without loss is wrong. Even Sigfox is already telling you the energy consumption for one package and two repeatings. And narrowband IoT has always at least one repeating included. So one package to compare is wrong. The second one is wrong is they always pick out one package on spreading factor 7. Yeah, they don't talk about spreading factor 12 and high package loss. And that is the reality.
Thanks, Harald. We've actually had another question in the Q&A from Alencio, and I don't understand the question, so I'm going to ask you anyway, and if we don't understand, Alencio can expand. Is version 3, in version 3 Things Network, what has improved? How has latency improved? The Things Network.
Yeah, this is interesting, this question. Yeah, yeah, it is included, but not listed, yeah. Latency comes up very often, yeah.
Yeah.
So I have closed the same questions out of my narrowband IoT versus LTM seminar. Yeah. The latency at 134 dB link budget is in the near of 1 second, and it is rising to estimated 10 seconds with 154 dB link budget. And if you do the same, with LTEM, then you have the same 10 seconds. Yes, there is no magic. Yeah, it's only radio. Yeah, latency. Yeah, a package with Sigfox is 6 seconds on the air. That means the traveling time of the two packages is 6 seconds. Yes, the package time of LoRaWAN on on 12 byte, is in the near of 2 seconds. Yes, so if you repeat it in 3 times, then you are 6 seconds again. And narrowband IoT is in the near of 10 seconds, with 54 dB link budget where LoRaWAN cannot transmit anymore. And if you go down to 144, then we're in the near of 2 seconds. So 2 seconds for narrowband IoT versus 6 seconds with LoRaWAN. 2 seconds with narrowband IoT and no interference versus 6 seconds with LoRaWAN, including the interference and the packet loss.
Thank you for answering that one as well, Harald.
Yeah.
I think we have people want to go in a little bit more detail. We're going to move on to the next presenter now, unless there's one more question. Oh, okay. We're going to take the next question and then we'll have the rest in the chat. Okay.
That is a good one.
How would you manage temporarily synchronous data? What's your suggestion for managing temporally synchronous data?
Yeah, it means that somebody is starting a new business. Which way to go, or?
Oh, maybe. Maybe Alencio, you can expand in the chat. So Harald and Alencio can have more of a chat in our chat. We've also had a request from Scott to have more detailed explanations, Harald. So we will move on to the next speaker now, though. So yeah. Harald, you've started some great discussions. Yeah.
Yeah, Michael, what you can do is you can collect all the questions together that we have done with our seminar as well. Mm-hmm. I will put all the questions in one file and will answer it by email to you, and you can spread it with all the listeners. There's no problem.
Fantastic. It's very generous of you, Harald. Thank you so much. And if anyone does have any questions, he's got his details up on there, and definitely check out Harald's blog. I've had lots of fun looking through it. Go ahead, Developer Steve.
No, I was going to say, yeah, amazing. Thank you. Yeah, I think we could have been geeking out for quite some time on this one.
Yeah, Harald is a wealth of knowledge, and I would look forward to hearing more from you.
Yeah, thanks again for listening, and I'm now listening to Robert. So
thank you. Yeah, hang around, even though your phone's ringing off the hook. That'd be great. I'm just going to share my screen for just a second to do a mini intro for. Stop sharing your screen and turn off your video and whatnot, and we'll see you in the chat. But the next presenter we've got is Robert May from SA Water. So the request for this presentation actually came out of our Discord, which I love. So Ali actually asked in the Discord, what do you guys want to hear in our next meetup? And someone actually asked a specific question about energy utilization, and one of our fabulous participants of the AusIOT meetup, Andy, actually suggested we speak to Rob. So thank you for everyone in your suggesting and your recommendation. We've got Rob today, and he's an optimization specialist in energy for SA Water. 16 years experience, which is fantastic in the municipal water and wastewater sector. Ugh, I'm tongue-tied. I haven't had enough coffee today. But I'll let Robert introduce a bit more about himself. And the topic of his discussion is going to be Zero Cost Energy Future Program from SA Water. Like I said, this is a topic where he's going to dive into the IoT side of things. I won't try to introduce any much more of it. I'll let Robert introduce it for himself. I'm really excited to hear more. I've done a bit of Googling and read some of the stuff SA Water has online, but it's really good always to hear from the expert themselves. So take it away. Rob, if you want to put your camera on, turn your microphone on or come off mute. And I'm going to stop sharing my screen.
Quickly to Harald, if you can stop sharing your screen, please. Just an FYI, you are still sharing your screen.
And Rob is sharing his screen as well. Yeah, perfect.
All right, there we go.
Well,
Thank
Rob,
you.
Cool. We've got Rob as well. We're going to slip back into the chat and leave Rob for the next half an hour with us. So take it away, Rob. Thank you.
No worries. Thanks, Michelle. And yeah, just a shout out to Andy from SA Water as well, who's sort of linked up to give me the opportunity to present. So happy to present. Maybe just to manage expectations. Thanks, I guess, for setting the context, Michelle. Traditionally, I'm not an IT expert at all. And the presentation, I guess, won't talk too much about, I guess, the IoT devices and the hardware and issues like that. My role at SA Water is more, what are we going to do with the data that we're getting from a lot of our sensors? So my typical role is building decision support systems to aid operators of water and wastewater systems. So I'm a consumer of a lot of the data that we generate through SCADA and IoT, and building intelligent systems to help day-to-day operations. So probably the complete other end of the spectrum, maybe, to Harold's presentation. I do share some similarities, though. I do spend a lot of my time explaining the difference between power and energy to a lot of people. And I love puns, especially ones about power. And I've only got half an hour, but could go on for weeks with puns. Just to give you an overview of SA Water, we are the water and wastewater services provider for the entire state of South Australia. And we've got about 1.7 million customers that we provide water and the entire state of South Australia. And that's a lot of kilometres of water mains, a lot of kilometres of wastewater mains, and then all the pumps, tanks, and things that connect them together. So we run the full spectrum from remote water resources management, River Murray operations and things like that, all the way down to the operation of big water and wastewater facilities, wastewater plants, and desalination plants as well. And then everything that happens from there to the customer tap as well. So yeah, the full gamut of water and wastewater services sits within our scope. And you can imagine, I guess, there's probably a lot of opportunities for IoT that we're starting to look at, probably others that we've only just scratched the surface on. And to be honest, the ZCEF project for energy management is probably not. We do have some IoT aspects that we're currently doing, and definitely there's some potential for IoT, given that you consider, for example, I guess one of the ones we'll talk about later is the number of small pump stations that we operate, or that don't really operate, they're just out there running with very simple control rules. There's a good opportunity from an energy management point of view to put in place devices that can smarten up a little bit the controls that we use at those pump stations that aren't necessarily operated, and just make them more intelligent through the application of IoT. So definitely a lot of opportunities that we can look at if we're not doing it already. And I guess maybe at the end of this presentation, that might inspire, I guess, future presentations, maybe on some of the other stuff that's happening in water as well. Even just the chat I had with Harold briefly prior to this. He's got a lot of interest in some of the stuff that we're also looking at in water as well. So our zero cost energy future project is really about, I'll say, managing the energy associated with the provision of all these services. 80% of the provision of water services is largely electricity for the operation of pumps and treatment plants. So that's 80% of the cost that you as a customer would pay on the bill is because of that electricity usage. Our team at SA Water is really focused on how can we bring that cost down and how can we optimize our use of energy to make sure that the cost of providing that service can be as low as it can be. And the zero cost energy future spun out of this idea of things that we could do to achieve that. And the idea of reducing our net cost, which is about $80 million per year, getting that down to zero and passing that saving on to our customers. That's the ambition, I guess. Part of the strategy is basically to install a large amount of solar PV. One thing that we've got a lot of in South Australia is open spaces and sunshine. And so we've leveraged the space available at our operational facilities. We're installing about 150 megawatts of power generation distributed across a large number of sites, about 33 locations. And this is sort of one of our biggest sites at one of our wastewater treatment plants. We've got sites that up to about 6 megawatts of total capacity, right down to 100 kilowatt sites that we've chucked on the roof of some of our smaller pumping stations and depots. So quite a range of size of facilities. you can sort of see some of the different technology we're using and where we've put it. This one's down at one of our wastewater plants at Christie's Beach. We sort of nestled that one in where we had some open space adjacent to our plant. So really trying to maximise the use of available land to get the maximum benefit from that PV that we can get. That's going to help offset our electricity consumption from the grid. And my job, I guess, is to understand how we make the best decisions operationally to get the maximum benefit from that. We've also got about 17 megawatts of battery energy storage going in. I'll talk a little bit about that later. This was a bit of paper that sat on my desk. I use this a lot to explain to people the context. And I've just made a nicer version of that for you. And really, if anybody's got in their garage at home, and you've got an app on your phone and you spend all day looking at how much your solar PV is generating on your roof, or what your battery charge is doing, and whether your dishwasher is running, maybe if you're like my dad, is running around at home, you know, shutting all the windows, turning the air conditioner off and on, depending on what's happening. We're basically doing the same at an industrial scale. We've now got solar PV behind our electricity meter. We've got some batteries at some sites as well. And then connected to that grid supply, we've also got our operational facility, which may be a pumping station or a treatment plant, which will be consuming energy. And I guess what we want to know at any given time, what should we be doing to get the best financial outcome, i.e. get the minimum cost of electricity for the operation of that site. So we still need to make sure that we keep our tanks full, that we can supply our customers with water, or that we can take their wastewater away. And all of that's done safely, and that we can keep our tanks as full as they need to be to ensure security of supply. But there's a few things we can do differently then to make sure that when we're pumping, that we're not using energy when it's expensive, and we're trying to maximise the use of cheap energy. And also, at all of our sites, we've actually got the ability to export any solar that we don't use. So just because we have solar behind the meter, we're actually free to export it, and we can get revenue from that export that can offset our consumption of energy at other times. And same with the batteries, we can choose when we charge and discharge. We may discharge to reduce our peak consumption. We may discharge to sell that energy to the grid if we've charged off solar, or if charged when it's cheaper. And so that financial equation basically happens every 5 minutes. Something else that we've done to keep our costs down is that we've switched our entire energy portfolio onto the spot market. So for those that you who may not be as familiar with that, the entire sort of eastern seaboard and Tasmania and South Australia are all connected on what's called the national electricity market, where wholesale energy is generated by all the power stations to satisfy the amount of demand throughout that entire grid. And there's a wholesale price that's determined by an optimisation engine run by AMO that sets the price for energy every 5 minutes. And so that spot price can fluctuate anywhere between -$1,000 up to $14,500, and typically would sit around about $10 to $50 at the moment, but can obviously change quite rapidly. If you're on a retail contract with someone like AGL, you're probably going to pay about $300 per megawatt hour, whereas on the wholesale market, the median price is probably around about $10 to $50. So we generated a saving just by switching to the wholesale price rather than going through a retailer for our energy. The downside is that we now need to be more vigilant about that price, because every 5 minutes it can change. And if we were pumping a large pumping station through a price event where the price was around about $14,500, which does happen, especially during summer, we can lose $500,000 in the space of 2 hours of pumping. So that's quite a lot of money if you're not paying attention. So the onus is now on us to basically monitor the spot price and then look at what our operational facilities are doing. We've got enough vision as to what the price is going to do over the next, say, 16 to 48 hours, and make sure that we can then manage these facilities to be prepared to turn off when the price looks like it's going to be high, and to do that safely. So that's the challenge that we've been faced with. I'm just going to skip that slide. Basically, we need to introduce a new capability into SA Water that allows us to monitor and analyze how our systems are going to behave and how we can set them up so that we can monitor our energy cost performance in real time. We need to create more energy awareness around the business. Previously, people just didn't really think about how much energy that they were using. The focus was more on energy efficiency rather than time of use. And so there's a bit of a change, I guess, around how we perceive energy and what energy awareness means now, and the fact that it's more real-time as opposed to long-term. And I guess there's an inherent complexity between interactions between the energy market and the complexity of water and wastewater systems that we need to understand. Water systems can't really ramp up and shut off every 5 minutes. And so we have to understand the limitations of those processes and how they can interact with an energy market where the price is changing every 5 minutes. And then what we want to do is build some systems that can help us make decisions. And it's really a crossover space where traditionally there's not a lot of solutions that you can just go and grab off the shelf to help you make those kind of decisions. So my role in SA Water is to help put in place what we're calling our energy management system. And we've boiled that down to 3 main capabilities. One, that we need to have that real-time intelligence and awareness as to what's happening. So a lot of sensors providing us with data as to what's happening at our facilities, what energy we're generating, what energy we're consuming, what consumers are demanding in terms of water, what the load on our systems might be. And also then putting that data into some simulation and analysis tools to help us do either some planning scenarios or do some optimizations and analysis on demand to make decisions in real time through that analysis. And that brings us then to our scheduling capability, where given a forecast of what's going to happen next, we can also do that same analysis to anticipate how systems should behave and help make decisions in real time, and put that into things like model predictive control strategies to help us operate our facilities in the best way in real time, given our forecast of the price or forecast of the solar PV that we might generate, and forecasts of what water demand or what wastewater inflows we might have. And in amongst this sits all of our sort of infrastructure that we have for getting that data and for doing things with it. Traditionally, we're a big user of SCADA. All of our systems throughout the state are connected through a common SCADA platform, fairly traditional industrial SCADA using a lot of Modbus, but increasingly now we're starting to use more and more IoT, either for cost reductions or just because we've got a lot of remote systems that it's difficult to connect up in the traditional way. And more increasingly using some smarter devices that are just natively IoT based rather than using traditional SCADA. I use our Historian, which was AusIOT Pi, to basically, and that feeds into our modelling and analysis tools. Our assets are fairly distributed throughout the entire state, so we rely heavily on GIS, which is pretty typical of water and wastewater utilities, where you've got pipes and pump stations all over the shop. You need to know where they are. And we use an enterprise asset management system as well to keep track of what assets we've got and things like that. So these are kind of our foundation systems, and we're building our energy management system really on top of that platform. What we've put in place, just to give you a quick overview of the sort of tool we've put in place, provided a, just going to drop out of this, I can show you through. We've got a dashboard that we've now got. Just bear with me for one sec. So we've got a dashboard, basically have a map of South. We basically view over the state what any of our assets are doing right now in terms of energy generation and energy consumption. We can see what are the main users. I can provide basically some tables where people can view what we're generating or what we're using. So that might be useful for someone who wants to know what's currently turned on and using a lot of energy when we come up to a price event, and they can quickly act to respond and turn things off if they need to. Same for solar power. One of the things we see a lot at the moment is that we often see negative prices in the energy market. Without going into the reason why, price can often drop to minus $100 to minus $500. We don't really want to be generating, so we can follow this and see what sites might be currently generating solar PV we can act to turn those off so we can avoid losing money by generating when prices are negative, things like that. So you can see, yeah, we've got quite a large number of sites covered here. They are quite distributed throughout the state, and a lot of that data is coming in through either SCADA or through IoT devices that are bringing in things like power generation, power consumption, and flow sensors and things like that that are monitoring our processes as well. So we get quite a lot of data. All that streams into our PI system, and we've surfaced that data through a product called PI Asset Framework, which we can then wrangle the data and provide, I guess, a more semantic asset hierarchy to present that data to our dashboards and the modeling tools. You can actually drill down if you go to any particular site. We can basically see what's happening at that site in more detail. And this is basically giving operators and viewers to what's happening at their power supply connection. They can see a forecast of what their bill might be for the month, and they don't get necessarily the same bill shock that they get at the end of the month, and can take actions sort of early on in the month to maybe mitigate any potential increase in the energy cost for their particular facility or multiple facilities if they're managing a region. So like I said before, if you've got solar PV and a battery at home, you probably have an app that you look at on your phone, and you can basically do this for your house, and you can just see what the impact is of maybe not running your dishwasher during peak energy times and things like that. We're really making those similar sorts of decisions, just at a larger, more industrial scale. And I guess this is a first step to provide our operators with that intelligence to have that information available throughout the entire state for all the facilities that are sort of significant energy generators or consumers. And that's really just about having that data stream coming in to provide people with that information. The second part of what we've done is to put in place a modeling capability to start analysing that data and make use of it in terms of optimising our decisions. Probably don't have the time to go into it a lot, but one of the solutions that we found that was readily available we can use for this is a modelling tool called Plexos. It's actually used a lot in the energy sector. We're probably one of the first water utilities to start using it in more or less a non-traditional way, but it does provide you with the ability to describe how energy generation systems and pumped water systems would behave when interacting with the energy market, and it then optimises the utilisation of both the energy generation assets and the so you can get the least cost outcome for a given period that you want to optimise over. It's built by Energy Exemplar, which is actually conveniently a company based here in Adelaide, but the software is used all around the world, and we've adopted that to help us analyse and optimise the operation of our pumping systems. And we can actually optimise quite complex, water networks. What we've actually done is we've built a wrapper application that then wraps around that modelling software. We bring in the data from our PI platform. We can stage optimization runs in real time and bring in the current system state into the modeling software. It'll run an analysis for 2 or 3 days or whatever our model defines, and it brings back to the operators a recommendation as to what the optimum schedule should be for a pumping station to give the least cost while making sure that we meet the constraints of making sure that tanks stay above their minimum level and that we provide enough water over that 2 or 3 day period that we're optimizing over. And that's then going to be used as an ongoing decision support tool for operators that have to schedule the operation of some of our larger pumping stations. These are shifting around about 300 to 400 megalitres of water per day, consuming a lot of energy. We might have 3 or 4 pump stations in a series on one pipeline that each consumes about 4 to 10 megawatts of energy at each pumping station. So quite big systems that use a lot of energy. We need to really make sure that the operators have got the best information available to help them minimise the cost of operating these. So that's basically mixing then the optimization analysis capability of Plexos with all of the real-time data coming in through our data platform that's also being visualized in that dashboard. So that's a new tool that we've kind of developed internally for our operators to use. And probably one of the more recent things that we've put in place as well, we're getting about 17 megawatts of battery energy storage capability. And we've procured a fleet of Tesla power packs for our project. And what we've put in place then is a software system to help optimize the interaction of those batteries with the energy market. And for some of the smaller sites, almost like an IoT approach to the way that those batteries are dispatched. So if anyone's got a power pack or a similar other brand of battery on their sort of garage wall, they'll see that those batteries typically come with the means of self-determining when is the best time to be charging and when is the best time to be discharging. And we're sort of doing the same with our industrial fleet of batteries. We've got some larger batteries. Our largest battery is 6 megawatts. Our smaller ones are typically 200 kilowatt batteries, so a bit smaller. For our larger batteries, these will be registered with AMO, so we need to make sure that they are bidding and interacting with the market's dispatch process, where energy generators have to submit a bid every 5 minutes that offers their capacity. If that capacity is accepted, i.e. the prices that they offer is good, they'll then be instructed to either charge or discharge, or instructed to generate if they're a solar system by AMO SCADA system. So in order to be, basically have to be in the market to be generating, and that's then applicable for our larger batteries. And what we've put in place is a layer that sits on top of our batteries called AutoBidder. It's been provided by Tesla. We've configured that up to basically use machine learning to forecast loads at the site. It'll forecast the price, and will forecast also the solar energy generation at a site where we may have a load, a solar PV, and a battery. And that system basically every 5 minutes updates the forecasts, optimizes the utilization, say 16 to 40 hours, by running a very similar optimization to what we do with our pumping systems. It then generates a bid that can go into the market system that reflects how we'd like to use the battery over the next 16 hours. And it sets the price as well to make sure that we maximize our chances of getting that dispatched. So that bid goes into AMO. They will then accept it, hopefully, send us some instructions, and then the battery gets dispatched through our SCADA system. And that basically rinses and repeats every 5 minutes and just runs continuously. With the smaller sites, we really don't have this need to bid, but the AutoBidder platform sends to the sites a price signal, and that battery runs a local optimization, again, very similar to the same optimization framework we're using either in AutoBidder or for our production scheduler case, and it optimizes the use of the battery at that site to minimize the cost of the operation of that site and maximize the benefit from the battery. Using that price signal that's coming down from the cloud through a 3G or 5G connection to the site, and then the battery sort of self-determining when it needs to be charging and when it needs to be discharging. So we've currently rolled that out at all of our smaller sites, and our largest battery has just started participating in the market. I can show a little bit what that platform looks like. I'll just jump to a screenshot. Sorry, a demo. So for me, this is kind of cool. We've now got the ability to look at our battery and see in real time what it's been doing. This little bar indicates the current time. We can see a projection as to what it's going to offer into the market over the next 40 hours. That's then translated into a projection as to what the battery's state of energy will be doing over the next 16 to 40 hours. And that's all based on a prediction of the price. And in the energy market, if you're not familiar with that, there's actually 9 products that the battery can offer into. One being energy, and the other 8 ones being related to what we call ancillary services, which are just basically small amounts of energy that either increase or lower the frequency to keep it at that 50 hertz set point that the power system in Australia needs. But either way, there's 9 products that the battery can offer, each with its own price, and it's optimizing every 5 minutes the utilization of the battery to get the maximum revenue from the battery over the next, say, 16 hours. And we basically then have a strategy that we can put in place with some different parameters that can figure out how the optimization behaves, and we can follow that. It's a little bit like a trading system, that we can use to maximise the revenue that we get from our battery fleet. And again, yeah, that's all powered, I guess, by that, bringing in the information real time, using some machine learning to optimize, to predict what's going to happen next, and then running an optimization to find the best set of decisions to take over the next, say, 16 to 40 hours, which is not too dissimilar to how we're trying to apply that then with our pumping stations. And so there's a fairly consistent theme, I guess, into how we're linking that all together. Now, I haven't talked a lot about IoT. I guess this is more about what we're doing with the information once we can get our hands on it. But I think there's some really good opportunities for IoT. A lot of the systems that we're currently focused on are bigger systems, but we do operate a lot of distributed pumping stations and devices that don't really get hooked in to our traditional SCADA. So probably the opportunities we're seeing at the moment is that, we are seeing a transition away from traditional SCADA, either due to cost reduction or just the technology is now becoming cheaper in IoT and becomes a preference to go through an IoT pathway rather than the traditional SCADA pathway for a lot of our distributed monitoring and control. We'd like to put in smarter devices, and there's a lot of work going on in what he referred to as smart networks, either for smart wastewater networks, or smart water networks, or smart maintenance. And a lot of IoT now is starting to be used in those applications, and that probably links into things like smart cities as well. And from an energy point of view, probably the simplest case that we can think of is a lot of our pumping stations, which typically run on a local control algorithm that just says, is my downstream tank empty or full? And if it's empty, pump turns on. Once the tank is full, the pump will then turn off. And it's a pretty basic control system. And from a demand response point of view, if we start to factor in what the market prices for energy, maybe looking at what the weather is and what our demand is going to be from our customers, we can quickly start to envisage a pretty incremental step away from that sort of very basic control method into something a little bit more sophisticated that's going to predict what the price for energy might be, what the weather might do, and what customer demand might do. Make better decisions to say, well, maybe the tank's a little bit empty, but the price for the next 3 hours is going to be more expensive, so I might actually turn on a little bit later and defer that pumping run by a couple of hours and avoid a price spike in the energy market. And you can quite easily see that would then give us enough, give a lot of cost reduction just by taking that small step away from level-only based control. And what's going to enable that kind of approach, these devices aren't often connected to SCADA and just run locally with only awareness of what the tank levels are doing. Just by providing that extra IoT capability and the awareness of what's happening in the energy market, it can sort of run still in an autonomous way, but with a slightly more sophisticated control approach that can, in the end of the day, result for us in significant cost savings for the operation of those pumps. Even if we don't have those connected to SCADA and they're not actively controlled, they can be configured with a control algorithm that provides us with a lot more benefit from an energy cost perspective as well. So I think that's probably just one particular use case that we can think of. There's potentially many more. We've obviously, for the time being, focused on some of our larger assets that tend to be more SCADA connected, but we can start to see, we've got hundreds of these pump stations around our networks, and these will be the next sort of thing that we start to look at. And I guess, it was mentioned earlier, I think one of the challenges that we've had, in particular with our batteries, some of our solar sites, these are now coming with inverters that are connected to the vendor's sort of cloud platform, either for maintenance reasons or to provide value-added maintenance portals and things like that through web connectivity. And that does present a huge challenge to us, in particular from a cybersecurity point of view. And there's a lot of discussions throughout our project around cybersecurity and how the use of IoT could be made to work within our cybersecurity constraints. In particular, with critical infrastructure like water and wastewater assets, obviously cybersecurity is quite important, and a lot of our SCADA networks tend to be heavily protected and often air-gapped and things like that to avoid or mitigate the risk of cyber attacks. And so obviously, being a bit sensitive about how we use IoT, how secure it is, and where and more we can't use it. Obviously, things like monitoring and read-only applications are a bit more benign. When we start to look at applications when we have active control of things that are moving water around, yeah, obviously people get a little more sensitive about that sort of thing. There's a lot more constraints on how much IoT we can use and where we use it. But I think we can still make some stuff work. We've managed to connect up our batteries and things like that within some of those constraints, and done that fairly successfully. It's just, I guess, a more rigorous process that we had to go through to make that work. So that's I guess all I wanted to share at this point. I'll probably open, so just say thanks again for your attention, and open for questions.
We do have a few questions. Thank you, Robert. I really enjoyed your presentation. It's fun to especially have someone from Adelaide talking about stuff that I know well, having been living with SA Water my whole life. We've also got when I was studying engineering at university, our teachers of the power systems course were always saying, like, power and energy are the most useful things you're going to learn. That's where all the money in business is going to be. And it's so funny to see SA Water, like a water utility company, so like involved in the power and energy system. Lots of the questions in the chat. There's lots of questions in the chat, I should say. Keep them coming, guys. I'm going to ask the first one, if that's okay. Can you use the water flow pressure to generate electricity? So we talked about solar a lot. What about using hydro?
Yeah, great question. We do actually do that at a number of places. So down at Seacliff, Adelaide.
By the beach.
And maybe you can still see it on my screen.
Yep.
Yeah, we've got little mini hydro there. So the water system loses about 100 to 200 meters of elevation as the water comes down the hills. We've got other ones also at Hope Valley. And these mini hydros generate about a megawatt of power just from the water flowing from one tank at the top of the hill down to a lower tank. So where possible, we try and utilise that. Obviously, if we do too much, people's shower pressure tends to drop. We get a lot of complaints, so obviously we need to be careful of that. But yeah, where there's opportunities to do it, we've definitely looked at that. And some people may not know, the desalination plant at Lonsdale, these things tend to be a bit of a beast in terms of energy consumption, but through the design of these plants, they actually take water up maybe about 50 meters from the ocean up a cliff to get to the plant. That consumes a bit of energy. They've put recovery turbines, so when the brine is released back out of the plant and into the ocean, as that water flows out, that energy is recovered, so they can get quite a big bit of their initial energy consumption back through that turbine as well. So
that's so cool. It almost becomes a meta utility, using the utility to power the utility.
Yeah, actually, and just I don't know if there's no question about the fun fact. I guess yeah, it seems strange that the water utility is into energy so much, but this is our treatment plant at Glenelg. We have biogas produced at our wastewater plants, and at 3 of our main plants in Adelaide, we generate energy by burning that biogas through engines that are then either used to power the plant, or now we can start selling that energy to the grid. And we're about 85% self-sufficient. In Europe, you can see plants that are 100% self-sufficient and can basically power themselves just on that biogas. And water utilities have been doing that. I think there's an old engine on display at the front of this plant, and the nameplate's around about 1947. So we've been doing it for a long time. And even before there was a market for carbon, or talk about zero carbon, we were already sort of doing that for quite some time. So yeah,
it's fantastic. I was so proud to hear that.
Next question up is why solar over wind or thermal or other renewables?
Yeah, good question. We looked at, I guess initially the idea was how could we bring our costs down. There's a bit of brainstorming that happened. There's often a lot of different ideas were explored. We had a trial of a unique thermal energy storage pilot at Glenelg is one of those sort of things we might look at. Wind, you need, I guess, a lot of space to spread out a number of turbines. Solar is definitely the cheapest if you've got land available. So in terms of megawatts per hectare, we get more bang for buck, I guess, putting in solar PV. One of the other questions we get is, why do you not just have one large solar farm? And we're actually trying to reduce our overall cost of electricity. Half of that is just for the energy. Another half is actually the cost you pay to your network service provider for the poles and wires in the power distribution network. And that's purely a function of what you use at your point of connection. There. And to go back to this slide here, it's about a 50-50 split in terms of what we pay for energy and what we pay for network services charges. The only way you can get that network service charge down to zero is to reduce the amount of energy that flows through your meter. And that sort of leads to a strategy where you're going to put a lot of solar behind your own meter, so it looks as though you're using less energy, and you'll get this charge reduced. But yeah, we looked at a bunch of different options, even some floating solar. We do have some reservoirs that could potentially provide a lot of space. It was either not cost effective or problematic. I think often people think it's a good idea at the time, and overseas we might have seen this done, but you need sunlight and things to maintain the health of your reservoir. Any biter and fish and things that keep the water quality good within your reservoir tend to suffer if you put a bunch of floating solar panels over the top and block the sunlight. So yeah, a few unwanted side effects, I guess, from some of those other approaches that we could have taken. But the short answer for wind and solar is that, yeah, wind, we don't quite get the same amount.
So I wonder if that has already answered the next question from Alencio, which is, what are your thoughts on microgrid architectures? So I guess that's the decentralized mini plants.
Yeah, look, I think I'd always advocate a horses for courses kind of approach. We often have the same argument about decentralization or centralization of water and wastewater utilities, and probably the economy of scale will be determined based on what's best for the project. But yeah, again, I'm not an energy expert. I guess I'm a water and wastewater guy, and so I really can't answer any more than that. But I think, yeah, microgrids have their place, but I guess it's going to be different depending on the socio-economic context that you find yourself in. And I guess it's a very general vague answer, but yeah.
No, that makes sense. With the water consumption modeling that you had up, well, also the power generation, I guess, but what do you see seasonal trend in the data sets and are able to ramp up, ramp down, production or throughput as needed?
Yeah, absolutely. Actually, we're on a multi-time scale sort of approach. We have a tool that forecasts out 2 years. It looks at environmental flows into rivers and our catchment. It determines how much water we need to pump, and also forecasts how much consumers are likely to use up around about 2 year time scale. So it's looking into maybe a course time step of weeks or months. That gives us sort of a budget from 1 month to the next as to how much water we might need to source from the River Murray, which is where we're doing a lot of pumping. And we have dry year scenarios, wet year scenarios, expected scenarios, and things like that we run through that software. That gives us an idea as to the range of what our energy consumption might be, and then through that, at a more real-time scale, maybe every 2 weeks, we run an analysis that says, okay, this week, how much water do we need to provide, based on that sort of more long-term analysis, and then that then feeds into our short-term schedule that says, okay, what's happening in the next 24 to 72 hours in terms of how much water we need to shift and what's the energy price going to be like. There's a lot of seasonality that comes into play in the energy market as well, so the two kind of overlap. Energy prices are typically cheaper on the weekend when demand drops off. We can see a lot of negative prices. And so where we've got discretion to run stuff, we'll typically favour running it on the weekend and use that weekly seasonality. Sometimes we can get basically paid to run our facility, which otherwise costs us a lot of money just by choosing a weekend rather than a weekday to run it.
Yeah, it's a fun tip for everyone too. If you're doing your washing or putting on your dishwasher or whatever, doing it during the day, right, when the sun is shining, is usually better.
Yeah, absolutely. Yeah, but actually, you don't want to use your solar. You want to, well, I guess you can.
Oh, it depends what price you got on your solar.
Well, absolutely, yeah, for sure, yep. There's actually some retailers that are passing through the spot price. If you look up, I think Amber Electric might be the only one at this point. There may be more, but you can now, as a consumer, get a spot price for your house. But again, you have to be careful. I don't know if anyone followed what happened in Texas earlier this year with the big freeze that they had. It caused a bit of havoc for their power system, and some consumers that were on a spot price energy tariff, weren't enjoying it so much because they had to pay the market cap for 1 or 2 hours.
That's when you were saying where it could swing to like from negative all the way to like tens of thousands, but the median is better, but you get those fluctuations.
Yeah, typical price saving would be $10 versus $300 for your energy that you're using. But yeah, if things go bad and you don't have your eye on the ball, it's like going overseas with your data roaming stuff.
Yeah. Hey, I might ask just one more question before we jump into before we close off the presentation and go back into the networking tables. If there's more questions for Robert, we'll just end this presentation and go on the table so we can ask them, or you can obviously put in the chat. So the last one I'll ask is on the topic of power failures. Are there any requirements for you to mandatorily discharge power at a power failure event? For example, power links being cut off.
Yeah, so I mean, AMO and SAPN, so everyone, I guess, that's got a connection with the power system has what's called a connection agreement, which is the terms under which you're allowed to connect. That typically dictates what you're allowed to generate, what you're allowed to import, what are your constraints, and also, at times you may be directed. So often we can be told to turn off. So that helps maintain power stability. It's a fairly controversial topic because I think they're trying to look at having that capability for rooftop solar. It's upset a lot of people recently because traditionally rooftop solar generates whenever it wants, and they can't turn it off, and that's creating a lot of instability in the power network. So we can get turned off just through SCADA signals that come into our site and just say, look, you can't generate right now, or you can't export right now. We're not necessarily, none of our load is registered to be scheduled. Some big aluminium smelters and things like that, they can have an agreement with AMO where, at times they'll agree that, if AMO wants us to run or they want us to turn off, we'll do so, and there's probably some financial compensation involved under that contract. Typically, it happens with a lot of large mining and energy customers, not with ours so much. We're happy to have our energy assets regulated in that way because there's only a financial impact if they turn on and off. Obviously, we're a bit more sensitive about turning off our wastewater plants and things like that because we can't stop the wastewater flow coming into the plant, and we need to treat it to avoid an environmental disaster. A lot of those things being critical, we typically don't have any arrangements where we need to turn those off under that kind of direction. And things like our batteries and things like that already provide FCAS as a service, so they're already helping to stabilize the power system as well. Our batteries are essentially a mini version of the big battery at Lonsdale, just at a smaller scale.
Yeah, if you guys haven't heard, SA's got the big battery. That's the one that Elon Musk made a bet. I don't know who he made a bet with. Made a bet he'd build the biggest battery in the world, and we have it just north of Adelaide.
Wasn't it Mike Cannon-Brookes? I think it might have been. I remember there was a Twitter thing, but
it was a Twitter thing.
Yeah,
it's epic. I've been out there. It's fun. So thank you again, Robert, for coming out and sharing that with us. It was actually super interesting, and I love definitely the difference in the topic and everything between you and Harald, even though you're both talking about energy. So I love that. We had lots of good questions for both of you, and let's continue the conversation. I might take over the screen though. Developer Steve, did you want to add anything while I'm getting the screen?
That was amazing. I always love seeing or hearing of IoT usage and utility monitoring and whatnot, because I mean that's just one of the ultimate geeky projects, right?
Exactly. Thank you again, Robert and Harald.
Thank you.
Speakers.
Oh, no, thank you.
Easy. And these guys will be available for a little bit longer in the networking session. I just wanted to plug some upcoming events we've got. So GovHack is this weekend. If you guys haven't heard of GovHack, it's the largest open data hackathon in the Southern Hemisphere. they were having physical events all over the country in multiple cities and in all of the states. Obviously, most of them have gone online now, which is great because we can all collaborate again together in teams. But it is state-based and city-based because a lot of the sponsors of the event are like state councils, state governments and local councils. So find out the state near you. I'll be there in Adelaide, and we're Telstra sponsoring with Microsoft. So that'll be a bit of fun times on Friday night and Saturday morning at the hackathon, all the way till Sunday. So if you guys are interested to join, you can join, or yeah, come see me there.
I'll be with the New Wales crew. Fun fact: there was going to be a GovHack Dubbo for the first time ever, and then there wasn't. So yeah, we're totally going to be all virtual this year, but everyone will be online. There's some great mentors. There's some amazing data sets. No surprises. Smart cities is a big topic across all of Australia. So get those IoT boards out and build stuff.
Yes, and agribusiness is one of the key ones as well. Our last AusIOT meetup was themed on agritech, and so agribusiness is going to be big at GovHack as well. I love GovHack. I was there a few years ago as well, and lots of the people that go there are like legit professional experts in their field, and some of the solutions are fantastic. Oh, there we go. That's us. So as we said, AusIOT, we're having them every month. So the next one would be September. These things come around really quickly. But as you saw tonight, we take suggestions for speakers. If you want to speak, if you have a project you want to share, as big or small as you want, if you have someone that you want to see speak, get them in contact with us. We do want to hear from more lady IoTists. We're always looking to hear some more female IoT specialty speakers. So special shout out to anyone who can bring us some more of those. And that's it. Thank you, everyone. I think that's the last slide. Oh,
it is.
Look at that.
The networking GIF.
So what do we do now, Developer Steve? How do we do the networking? Give us a reminder.
Thank you all for coming, and yeah, jump around the tables, chat to folks. Everyone will be running around the venue, so yeah, stick around and say hi to someone.
Yeah, and we'll be here for at least another half an hour. I think it'll be open, and then the event will close and we'll all get kicked out, and then we'll see you in the Discord channel.
Totally see you in the Discord.
9 p.m. You've got plenty of time left of curfew yet.
Fantastic.
I'm in Melbourne.
Thanks, Ali.
Thanks for coming, everyone. Thanks, speakers.
Thanks, Ali.